Most of the chemical reactions you'll likely encounter are those that take place in a liquid solution. So we need to have some good ways of quantifying the amount of our reactants in that solution, and that's what we'll be talking about in this video. Our learning goals are how to quantify how much solute is present in a given solution. So let's start with the definitions. Concentration basically is telling us how much solute there is in a given amount of solution. That given amount could be either a volume or a mass. So this concentration that we're providing is an intensive property of the solution, not an extensive property. In other words, the concentration is going to be the same no matter how much of that solution we have. It's not going to double if we double the amount of solution. It will stay the same if we double the amount of solution because it is telling us something that is intensive about the property of that solution. So we're going to define concentration to be an amount of solute divided by an amount of solution. And one way we could do this, and in fact the most common way, is to take the moles of our solute and divide by the liters of our solution. Now, it turns out when we do this, it defines a unit called molarity, and that molarity is the most common way that we use to express concentration for solutions in chemistry. So let's see how this works. We're going to try an example here of sodium nitrate in water. We're going to dissolve 0.824 moles of sodium nitrate in 250 mils of water, and we want to know what the molarity of the resulting solution is going to be. Well, we need to make sure we have the appropriate units. We need moles of solute, which we have, and we need liters of solvent, and we don't have that. So we're going to need to convert our milliliters into liters, and the conversion factor is 1 liter is equal to 1,000 milliliters. So 250 mils is equal to 0.250 liters. It's useful to be able to make that conversion fairly readily in your head if you can. It's all it takes is a division by 1,000. So now the concentration of our solution is going to be given by the following calculation. I'm using C to represent concentration, but it basically is the number of moles of solute, 0.824, divided by the liters of solution, 0.25, and we would find that when I make this division, it's 3.30 molar. And the units, the label that we give for molarity is a capital M. So now let's do some work with this molarity, with this solution. Let's suppose that I extract 100 mils of this 250 mil solution, and I want to know how many moles of sodium nitrate are present in my 100 mil sample. How would I figure that out? Well, what I have is 100 mils of solution. What I want is how many moles of the solute are present in that solution. And the conversion that I'm going to need is, first I'm going to have to convert mils to liters, because whenever I'm dealing with the molarity in solutions, I need to be in liters. And then I'm going to need to convert from liters to moles of solute somehow. Well, that second conversion is simply the molarity of our solution. So this is the way the calculation would look. I have 100 mils of the solution. I'm going to convert that to liters, so I divide by 1,000 mils, multiply by a liter. And then I multiply by the concentration. Remember that molarity effectively is moles per liter. So if I multiply by 3.3 moles in every liter of that solution, and then I multiply it by the amount that I actually have, I would find that there are 0.33 moles of sodium nitrate in that amount. So it's very simple. I just multiply the volume times the molarity to get the number of moles present. So this is a general relationship. If we multiply the volume times the concentration, it will always tell us the amount of the solute that we have present. Now it turns out that this is a very useful relationship, and we can use it to figure out a number of other things as well. One of those is dilution. So dilution is basically when we add a solvent to our solution to reduce the concentration. So I've got 250 mils of solvent here. If I add more water to that, 250 mils of solution. If I add more solvent to that, more water, I'm going to cause the concentration to go down because there will be the same amount of sodium nitrate, but I'll have now more solution. So one question we might ask is, how much water would I have to add in order to reduce this concentration from 3.3 to 3.0? Now remember, I mentioned that the moles of solute does not change. I am not adding or subtracting sodium nitrate from this solution. All I'm doing is adding water to it. So it basically means that when I multiply the concentration times the volume, it equals the concentration on the volume with the new volume, because this product of concentration times volume is the number of moles of the solute. Since that didn't change, these two have to be equal to one another. So now I can set this up in the following way. I have a 250 ml solution, or 0.25 liters, that has a concentration of 3.3. That when I multiply those together, it tells me how many moles. Remember, that was 0.824. It tells me how many moles of solute I have. Now I'm going to add water until the concentration is 3.0, but now it will have a new volume. I don't know that volume yet, but I can figure it out because it's the only unknown in this very simple equation. So now if I divide both sides by 3.0, I can solve for the volume, and when I do that, I find that the new volume is 0.275 liters, which is equivalent to 275 mils. So now all I need to do is subtract the amount I originally had to get the amount that I had to add in order to reduce the concentration to this amount. I hope this made sense. Please ask questions if you aren't following this at all. I'm happy to answer any questions you might have about solutions and dilutions.